Welcome to The Explainer. If you're looking to understand how frontier technologies are actively driving real-world business value right now, you are in the exact right place. Today we're tearing down this lingering myth that quantum computing is just some far-off sci-fi concept. We're going to look at hard data, actual benchmarks, and active enterprise deployments to uncover the real-world ROI of quantum technology. Okay, let's dive into this.
I want to kick things off by completely dismantling the hype. It's so easy to fall into the trap of thinking quantum computing is just a future science experiment locked away in university physics labs. But as this quote from D-Wave makes absolutely clear, for businesses looking to solve their toughest optimization problems, this technology is very much here today. It's already active, it's operating in commercial enterprise environments, and it's delivering tangible advantages right now.
So here's our roadmap for The Explainer. We'll start with a quick quantum reality check. Then look at how we defend with quantum security. From there, we'll advance into complex optimization, specifically breakthroughs in logistics, auto, finance, and healthcare. And finally, we'll wrap up with actionable steps for building a quantum-ready future.
Let's jump right into part 1, the quantum reality check. For our purposes today, I want us to completely redefine quantum computing in business terms. Let's forget the deep physics for a second. No superposition, no entanglement. Just think of it as a superior operational tool. It's a system designed to process incredibly high-dimensional data and evaluate massive parallel scenarios for complex optimization. Where a classical computer has to look at solutions sequentially, like one by one, a quantum system can evaluate thousands of competing scenarios in parallel to find the absolute best path forward.
And hey, this isn't just theoretical anymore. Based on data from Hyperion Research, 1 in 7 enterprises, that's roughly 14%, currently have a proof of concept or a live production use case for quantum computing. Think about that. Leading organizations globally aren't just sitting on the sidelines waiting. They're actively building in-house quantum capabilities today so they aren't left behind tomorrow.
Moving on to part 2, defend deploying quantum security.
So, there's an immediate massive threat facing literally every major industry today. Current classical cryptography, things like RSA and ECC, secure everything from our online banking to global telecom networks. But they are completely vulnerable to a strategy known as Harvest Now, Decrypt Later. Bad actors are actively stealing encrypted data today, just sitting on it, waiting for quantum computers to get powerful enough to crack it open. And this brilliantly illustrates why post-quantum cryptography, or PQC, is an absolute necessity right now for achieving cryptographic agility and resilience against these future attacks. Now, if you're wondering if you should really care about this yet, take a look at these concrete real-world deployments. Quantum security is an active operational reality protecting critical infrastructure today. Banco Sabadell partnered with Quisecure for a massive PQC pilot that actually got recognized by the SEC. Cloudflare recently reported that over 65% of human-generated web traffic is already using post-quantum encryption. Telecom carriers are migrating their 5G cores, and Toshiba has active fiber-based quantum key distribution networks running in Tokyo and London as we speak. This is happening.
All right, on to part 3, advance, solving complex optimization.
The absolute most important thing to understand here is that companies aren't just waiting around for the perfect, error-free, universal quantum computer to be built. Instead, they're using what we call hybrid quantum classical workflows. Basically, they take a massive problem, let their traditional supercomputers handle the bulk of it, and then farm out the absolute hardest, most complex subproblems to a quantum solver. By integrating these hybrid setups into their existing IT infrastructure, they're getting immediate results and overcoming the limitations of classical computing right now.
Let's see what that looks like in part 4, logistics and automotive breakthroughs.
To really ground these software concepts in physical reality, check out the massive D-Wave Advantage system. This isn't just a lab experiment. Volkswagen actually utilized D-Wave's technology for the world's first active hybrid quantum production application, specifically designed to tackle the incredibly complex problem of commercial logistics and traffic routing.
Let's hit the actual metrics of that Volkswagen deployment because they are wild. By using a quantum hybrid solver to dynamically route a fleet of buses in Lisbon, Portugal, Volkswagen was able to bypass traffic bottlenecks and achieve a massive 30% reduction in transit times. Seriously, think about the fuel saved, the emissions reduced, and the efficiency gained just by optimizing routes that classical computers simply struggle to process in real time.
So the crucial point is that this kind of optimization translates directly to massive financial savings across the supply chain. In a totally separate application, Volkswagen applied quantum solvers to their factory paint shop scheduling. By optimizing the sequence of cars going through the paint lines, they achieved an 80% reduction in paint color switches. No joke, that reduction alone increased total factory throughput by 15%, saving an estimated millions of euros annually in wasted paint and solvents. That's a real game changer.
Let's move to other global industries and see how this builds. It's definitely not just automotive. Aerospace giant Airbus used quantum algorithms to achieve optimal cargo configurations, perfectly balancing weight and shear limits to minimize aircraft fuel burn. Over in the energy sector, ExxonMobil used a hybrid classical quantum approach to optimize their multi-port fleet of LNG tankers. When they simulated heavy storm disruptions, the quantum model allowed for a 20% faster recovery and rerouting of tankers compared to traditional methods. Huge operational wins.
Let's switch gears to part 5, transforming finance and healthcare.
Now, what's really interesting about this data is just how staggering the enterprise benchmarks are across these data-heavy fields. At HSBC, by using quantum feature maps, they achieved up to a 34% relative improvement in their trade fill predictions for algorithmic bond trading. Over at BBVA, dynamic portfolio optimization that traditionally took about 2 entire days to compute was reduced to literally seconds. And in healthcare, Biogen is using quantum-inspired algorithms for molecular comparison, successfully accelerating their early-stage drug screening processes. These institutions are processing high-dimensional data to drive massive ROI today. Which brings us to our final section, Part 6, Building a Quantum-Ready Future.
Here's the tactical playbook outlined by McKinsey for leaders who want to get ahead of this curve. Step 1. Map your specific business problems to potential quantum solutions. Step 2. Identify your highest friction points. We're talking about those high-value R&D or combinatorial optimization use cases where classical computing is currently holding you back. And step 3, don't try to do the whole shebang in-house from scratch. Invest in partnerships with quantum vendors and begin piloting hybrid workflows right now. You absolutely need to start testing before the competitive divide becomes insurmountable.
And that leads us to our final thought for this explainer. The competitive divide isn't a problem for a decade from now. It is forming today, right under our noses. The organizations that recognize this are already making their moves. So, pose the question to yourself and your team. Will you defend your data and advance your operations, or will you be left behind? This video is based on 223 sources and designed by Spectre AI.